This is going to be very, very exciting. My next guest is an art director for an ad agency. 15 years ago, he sat down at the kitchen table to make a paper airplane for his son, and he came up with a design that violates the laws of aerodynamics and yet unbelievably flies, ladies and gentlemen. And experts say that it flies a lot better than airplane designs currently in use. The story is right here in this current issue of Omni magazine. Also, it contains a cutout fold-up model of the same aircraft. Please welcome Mr. Richard Kline. Come on over here and tell me about this airplane. Now, this is it's going to be something unlike we've ever seen in aerodynamics, right?
Well, we think so. We have what we think might be a whole new concept in aerodynamics. And it's based on a discontinuity of surface here on this airfoil, which traps a pocket of air turbulence, we believe. It's been tested a number of times, and whether the airfoil chord section right side up or upside down is tested, it will not stall up to 45 degrees
now,
angle.
I'm guessing 90% of the people watching now have no idea what you're talking about. Let's first of all, let's just start here. It looks like any folded paper airplane that anybody would stumble across. Mm-hmm. How then is it radically different from paper airplanes we make or what is actually in the sky now?
Well, what's in the sky now doesn't have this discontinuity of surface.
Okay, now don't use that word.
All right, okay.
It doesn't have one of these little deals, right?
That would be solid, by the way. That wouldn't be hollow. It would be a solid surface, but abrupt.
Oh, I see. It would be. There would be a like another level.
Yes.
Okay. So, and what does that provide for the airplane?
Well, we think it provides. It traps some of the air turbulence. See, this pushes air out of the way.
Which are you talking about?
The wing. All right.
Okay.
It displaces air.
Mm-hmm.
Now that air has nowhere to go except to create drag. All right. But there's a pocket there which the drag or air turbulence falls into and is trapped there. Mm-hmm. Okay, and that enables this aircraft then to fly at all times it's level with the Earth. We've flown radio-controlled aircraft, and you have to force it into a spin. It just doesn't want to crash.
That's no fun, is it? But okay, so what you're saying is this little wall back there, the air is sucked under the wing and is trapped there and somehow stabilized.
Yes, correct.
Now are people who build aircraft saying, "This is it"?
No, they're not.
Now, why aren't they responding?
Well, because they really don't understand why it works or how it works. They test it under normal conditions, lift over drag, as they call it. Uh-huh. And this doesn't produce a high amount of lift. But there's something else going on that only now we're beginning to learn about. In fact, Scott Morris, who wrote the article in Omni, shocked me. I couldn't believe it when he had a discussion with a man out at Amerijet who claims that this airfoil may be 25 to 35% more efficient. And we think it's due to the fact that it's causing a forward action of a kind. Mm-hmm. The molecules are pushing it forward.
So it's reinforcing the lift and also the momentum. Is that?
Yeah. And it's also been tested on a propeller blade, and it pulled a pound more of thrust. So something is going on in that discontinuity or step.
Damn, this is exciting. Now. It's actually very fascinating. Now, do me a favor.
Yeah.
Explain in very simple terms the principle of lift. Why is it a 300,000-pound 747 stays 39,000 feet above the surface of the Earth?
All right. You'll get a couple of different opinions on why it flies. One is Bernoulli.
You mean we're not sure?
No way. You see, there's no one answer to anything.
Good Lord, I thought we had that nailed down by now. I know. Cut down on my flying if...
Now, they have what they call Bernoulli's principle, okay? And the idea is that on a curved upper surface of an airplane wing, you force the molecules to move faster. Because they move faster, there's less pressure, so you get lift from underneath.
The aircraft is actually being sucked into the sky, so to speak, isn't it? I mean, a stretch of...
Pushed more.
Okay.
Yeah, but that's not the only answer, because Isaac Newton once said for every action there's a like and opposite reaction. So as the airplane is pushing against the air is pushing back, and so you're also getting lift because they're finding air turbulence below the aircraft and behind it. So something else is happening as well.
Okay, and this little deal accumulates some of that air under this little cantilever.
We believe it does. As a matter of fact, if I may, on the 60 Minutes segment, it showed the plane like stabilizing itself, always in flight. It'll always tend to level off. And we think what happens is when it turns like this, the pressure increases and just forces it level. Okay.
Now, what's the biggest prototype or model of this you've got?
A 5-foot wingspan, radio-controlled model.
With little tiny stewardesses.
Right. How did you...
Okay. So, but you think eventually there will be a larger motor-driven
Amerijet
pilot?
Well, yeah, they hope to have a 2-seater in the air in 2 years.
Okay, let's go ahead and fly some of these guys. Richard, do you know where we're going to throw these? Now, will people be amazed at how much better they fly than regular model airplanes?
If it works.
Okay. Oh! Whoa! That was...
Sorry about that.
That was... Try that again, Richard. That was pretty impressive. I don't... Ooh, that was not so. May I try one?
Yeah, sure.
Okay. All right, go ahead. I don't know. I'm apparently doing something wrong.
No, you're...
Ooh. Well, we're out of planes. Oh, yeah, let me try another one. Richard, here, give this one a really nice... Let's see how far up in the seat you can get it.
Right.
See, the problem is the thing actually starts to climb and our ceiling is too low.
Yeah, I could have aimed lower and...
All right. Well, they certainly seem to be quite streamlined, don't they? They just... Oh, my God. All right, let's see. We out of time here? All right, Richard. Very nice. Thanks, Bill. Yeah, we just don't have enough room here. Right. It's fascinating. I tell you what, when you get the real thing built, come back and let us know how things are going.
Okay, very
interesting, Richard. Nice meeting you. We'll be right back with Rich Hall, folks.